All right, we're into part three of our Tech Talks this evening. And our next presenter is a face that will be well known to a lot of you here, Frank Kelly. Frank is a technical manager in Ericsson here in Athlone with responsibilities for automation and data analytics. So Frank is going to talk tonight about machine learning. And my interesting fact about Frank is that yesterday he discovered that he'd have to make this presentation without a slide deck. So, so bear with Frank. I know he's going to be very good, but give him your support. So, Frank Kelly.
Okay, I have two small kids, okay, and they don't sleep much. So, whatever memory I had before the slides, it's definitely gone now. So what we're going to do is we'll try and do this, and we'll try and paint some pictures with words, okay? And I know a few of you have been sampling the local hospitality a bit too much, so some of those pictures, it's just as well we're not projecting them up on the background here yet. You know? So where we'll start, I think, is with a story I told in our own Tech Talk in Athlone in Ericsson. And the story is about Windows 95. And when I told that story, I actually realized as I was telling it that there was a good group of the people that were listening to me actually weren't born when this software was out. And that kind of prompted a midlife crisis, which kind of threw me a little bit as I was giving the talk, but then it kind of calmed down a little bit. And but okay, so imagine there is operating systems back in Windows back in 95, and imagine there's games, okay, and there was a game called SimCity. And what SimCity used to do is it was a bit kind of loose with the way it used to handle the memory that it was allocated by the operating system. And it used to say that it used to free up the memory, but actually it didn't. And this used to kind of cause crashes within the operating system, and everybody would get kind of annoyed with Microsoft. And so Microsoft decided, okay, what we'll do is we'll put this explicit kind of fix in there that says if SimCity is running, make sure that the memory is freed up properly afterwards, okay? So they had to do that, and then they did that for the next version of SimCity when it came along, and the next version, and the next version. And then what happened was another piece of software did the same problem, so they put a fix in for that, and a fix in for that. And what happened was they ended up putting in this fix 6,520 times, okay? And if you kind of imagine some poor soul that had to go down to his local Walmart and take all the software off the shelf and lump it into a trolley and wheel the trolley back and test it all. That's exactly what happened. And a guy wrote a blog about it. Okay, so what it actually tells us, why did I tell this story? Well, it tells us, first of all, we have to tell computers everything, or we had to. And second of all, we have a need for automation. We need to be able to automate these types of things, these kind of tedious kind of tasks. And that's what a large part of my work and my team's work in Ericsson is about. So I guess as we kind of look forward in automation, we've seen that computers have got more advanced. Okay, so we had, I won't say Commodore 64s and all that kind of stuff. Like, I'm really going to like isolate that. But we've come from that to all these kind of supercomputers. We've advanced in cloud computing. The languages that we use to actually program the computers have got better. So these kind of higher order languages have grown, like so Java and Go and Python and Scala. Like there's all these kind of, I cut my teeth in C and assembler, okay? So, and then alongside that, you've got this growth of open source. So there's a huge amount of software and frameworks out there for people to pull down and actually do a lot of cool things with that you never would have had access to before. And what that has allowed us to get to is a point where we can actually do in industry, and people even at home can do automation. And automation is where a lot of our business is and where a lot of our business is going. And automation, if you kind of view it as a loop or a kind of an architectural diagram, this is where I needed the slide, but we'll go with it, right? So imagine there's 3 elements to it. Okay, so there's an analytics part, a policy part, and an execution part. Okay, so the analytics determines what's going on. The policy says this is what you're allowed to do when you determine something, and the execution bit just does what it's told. So what the systems that we work with in Ericsson and with others do is they ascertain what's going on, they make a decision within a kind of a policy, and then they act within it. And that's the basis of an automation system. But where we are now is actually we're moving from automation to something called autonomics. And this is where machine learning kind of comes into the story. So previously we had something called, we have automation. So what's the difference? The difference is if you consider your car, right? And you're driving your car and you put your foot down on the accelerator, and what you expect is the car will get faster. So a set of known actions happen, and they're well defined. You know what happens, except if you're driving that Yaris that was in front of me on the way in. I don't think that thing even haven't had an accelerator. And I was rushing to get in here. But you know what happens. You press the accelerator, the system gets faster. You take your foot off the accelerator, the system gets slower. That's automation. Autonomics is you press the accelerator and the system decides whether it's going to get faster or not. And that's a kind of profound kind of change. And this is where the machine learning stuff comes in for us. And it's kind of been an interest point in, what probably got a lot of you people into the professions that you're in. Arthur C. Clarke, all these kind of science fiction stuff. So Blade Runner, all that kind of stuff. Like, how intelligent can you make the machines? Like that was always kind of an interesting point to everybody, and it continues to be an interest. How far can we go? And I kind of talk about it a little bit later, but I think there's a couple of things. There was one thing that I was looking at, and it was this thing called the Turing test that people do. Mingzhu, you're nodding there, you know what this is. But, okay, if you imagine a kind of a Venn diagram here, all right, so on the right, on the left, so on the left, you've got human stupidity, okay? Now, you can fill in whatever you want there as the picture that you're thinking of for human stupidity, right? And on the right here, you've got the kind of stuff that only a computer could do, only those kind of rapid calculations that a computer can do, right? And then in the middle is what a human is. Okay, so a human is a mixture between the sublime and the ridiculous. And I think I got it the right way around just to prove. Because humans make mistakes and they make typos and they do all these kind of strange things. So you know that a computer, when it's doing something, that if it doesn't make those mistakes, or if it makes some really thunderous mistakes, then. So the Turing test was designed for people to actually look and see. They look at a terminal and they talk to the thing and they see kind of the thing, how close are we getting to actually a computer that can actually think. And so we've come that far with things, and machine learning is the enabler for this. And I guess there's a kind of a vision of this kind of brighter, better future that's enabled by autonomics. And it'll allow humans to kind of evolve into these higher order beings, visual picture, the Kardashians, and the computers to evolve into these higher order beings, visual picture, Terminator 2. So there's no worry about our future, I think, in that kind of scenario. So, but I'll come back to that because there's a bit of a personal reflection at the end of this about the future. But okay, so what do we do? What do we do in Ericsson? The problem space that we deal with networks. Okay, so telecom networks. And for people that don't know, telecom networks are made up of hundreds, maybe thousands of different parts, and we call them nodes. But they are essentially our computers, or RF equipment, or transmission equipment, or things for relaying, etc., things for billing. There's lots of different. Some of them are inside, buried in car parks, in data centers. Some of them are out on the top of mountains, being beaten by the weather, subject to all sorts of things, being hit by people, whatever. And so you've got all these kind of, the network is a kind of a chaotic thing, and it's generating a lot of data as things are happening to it. And then on top of this, you've got people. People are going and screwing up the network. So what people are coming in, they're going and they're moving all around it, and they're making calls, and they're generating data, and they're swamping different parts of the network as they move around, and that's creating chaos on top of it. So networks, to keep them up and running, are very difficult, and we actually, one of the features that we do is we can actually see what people are doing individually within the network. So maybe I shouldn't talk about that, but you probably generated about 1 megabyte of data on your way here, and somebody has actually stored that in one of these types of systems. So as the subscribers are moving around, we're capturing all that data, the network is generating data, and the software on the network. So another factor is that the software itself could have faults or misconfigurations, etc. So there's a lot of different factors that make a network hard to manage, and what we've traditionally done is we take all of that data that's generated and we put it into a big kind of data lake, and then we try and find insights, business insights out of that by querying it and looking for or having set reports, etc. And we've made successful business out of that, very successful business. Others have, and it's not bespoke just to telecoms, it's done in all sorts of areas. And but really, the kind of challenge going forward is that telecom networks are getting more complicated, and that means you have to store more and more data. So when you go to a customer and you try to give them the same proposition that you gave them before, or the same kind of value, you may have to go and say to them, instead of giving you 10 boxes or 20 boxes of hardware, I'm going to give you 100 or 150. And they'll say, not really interested. Okay, so efficiency in what we're doing has to really improve. So that's where machine learning and autonomics comes in for us. That's the kind of problem. We have a more complex problem to deal with, and we have to be better at dealing with it. And that's why we're exploring machine learning. So I guess, what do we do with machine learning? Well, to kind of explain a few of the concepts, I guess the first thing maybe we could cover is Pavlov's bell. So you know the thing for when the guy used to ring the bell and he used to feed the dog, and the dog would expect then after a certain point that he'd start to salivate even if he heard the bell and there was no food. You know? So we kind of train the dog that something's going to happen. And what we do is we have algorithms that look at the network, and we take a lot of data in, and we start to train through those algorithms what way we expect the network to behave. So we find a kind of a signature of what's going on. We pass all the data through it. And what we can do is, first of all, we can understand all the data that's come in, understand this signature, and we can make a prediction as to what's going to happen down the line. And we do that with a kind of a certain level of confidence. And presently, with the work that we do, we can actually predict it quite well. And it's quite interesting kind of field to be able to see how accurate you could make these. So we end up doing a lot of kind of tweaking of the algorithms and using different algorithms to see, can we combine them and make them more accurate. So also what we can do is we can understand a kind of a higher bound of performance in a network, and we can understand the lower bound, and then we can expect, if you consider it like a tunnel, that the behavior within that system should always be somewhere in the middle. And whenever it goes out the higher or the lower bound, then we have what we call an anomaly. So an anomaly means something is after happening that is potentially interesting. Okay? So when that happens, that's an interesting piece of information to the operator, and we give it to them. The operator are the people we're selling these systems to. And we have, instead of giving them massive amount of data or kind of simple reports, we've given them something that actually has been learned. And we have not, I guess the key point here is we have not pre-programmed this network. We have not set kind of explicit bounds. We've not set any kind of thresholds ourselves. We don't program them in. We learn it for the network. And that means we can go to another network and we can learn it. And we can go to another network and learn it. We don't have to go and have everything hard-coded and find out exactly, we'll hard-code it for your network, and then, because that would be really crap business. And that's what we allowed. So we can, because these networks are so chaotic, then it means we can actually easily we can easily produce these algorithms that allow us to understand these networks very well, and then we can present that back to the operators. Second thing we can do, clustering. So what was the example? Oh yeah, chaos theory, yeah. So chaos theory, I know nothing about chaos theory. I went to Wikipedia. The reason I found it was I was trying to find out the thing about the butterfly flaps its wings on one side of the world and it causes a tornado on the other. Okay, and that's apparently is chaos theory. There's definitely people in this room who will be able to explain it better than me. But for me, what that talks about is the relationships between things. And what we can do with our algorithms is, because the networks are so complex, we can actually understand relationships between things that are not apparent, and we can find them. So where a human might struggle to see them, the computer would be able to pick them up, or the algorithm would be able to pick them up. So we can see, for instance, maybe a microwave link over here is causing a problem, and that could be affecting somebody's the performance that somebody's appearing, or that somebody's getting way over here. And we find those relationships through the data. The algorithms are trained to find those types of relationships. And what we can actually then start to do is, again, without explicitly programming, we can, through the data passing through these algorithms, we can understand that because there's some sort of relationship between these things, maybe they're actually right beside each other, or have some direct relationship. And we can start to build up a view of these complex networks in real time without actually telling the network what way it's set up at all. And that's kind of a profound thing. Now, that's with an estimation. There's an accuracy associated with that. It could be 80%, 90% accurate. It could be just for a sub-network. It could be for the whole network. But we've actually found that we can do it. Definitely, we can find relationships and we can build these things up. So that means we're not explicitly programming anything. We're just passing the data through these kind of filters or algorithms, and they're finding the relationships and building it. So it's like a second view of the whole thing. I guess the last thing is that we have these things called recommender systems. And because when you find things, like what we're trying to do is automate everything. So when you find these relationships, when you find things that are interesting, that's cool. Okay, and you can present those back to people, but what people really want to do is not to have to lift a finger or less eyes on the glass kind of mentality. So kind of like the Kardashians maybe, you know. But what we need to do then is we want the operators to have to intervene less with the systems, but we have to learn what the operators do typically when these problems arise. So a problem arises, we say, here's a problem. We look at what the operator does, we start to learn what the operator does, and then once we've learned it, we start to recommend that back to them and say, well, typically what you do in this scenario is you do the following. Would you like me to do it for you? And then eventually they may start clicking yes, and then when they start clicking yes, then we'll start doing this all the time. And we do this a lot in different fields. I'll talk about that in a second, but it's transferring the knowledge that's in the human into the computer. And you still need to have that. And definitely in our experience, nobody will trust a machine with millions and millions of dollars worth of equipment. Nobody will trust a machine initially to do anything. You have to allow a certain amount of what we call open loop action, where the operator or somebody's in the middle, and then over time they'll start to trust it, and then they'll start to let the machine start to do the work. So that brings an important kind of a thing where, if you look at it, machine learning is one thing, and it allows us to actually train the machines through the algorithms, but you can't get away from the fact that you still have to have a human provide an initial, at least, information into the system. And we call that domain knowledge. So in Ericsson, we understand networks really well. And networks are really hard things to understand. And there's a value in that. And the best people for us are the people that can understand the machine learning and have that kind of domain knowledge. And that's what we bring to the table. We combine these two things. Now, other things maybe that are associated with machine learning, other fields may be more intuitive for people. But for somebody walking off the street, if you ask them whether this problem or this anomaly that's coming up in an LTE network, is this something that we should make this effect or make this change for, they won't have a clue. Okay? Maybe if it's deciding about other things in the supply chain or something like that, people can make an educated guess on it. But you really still need to have that kind of understanding of the net, that deep understanding, and then you feed that to the machine, and then over time, that's not needed to be said again, and the system also learns the behavior and what to do. So where we apply these types of this logic and these different types of systems, first thing, a lot of it is around optimization. So resource optimization within these networks. Everybody wants to improve their bottom line. So as part of improving the bottom line, you've got to get the most out of what you have. And a lot of the guys sitting here at the front, when they've had a few pints, they'll tell you a little bit more about things called SON, self-optimizing networks. Okay, so we do a lot of that. So that means that the network itself actually starts to adopt. So where I was talking before about all the subscribers as they move around and they cause all these problems, and they put pressure on different parts of the system itself, the network itself, through the algorithms, through the machine learning that we put into it, can actually start to physically adopt itself and improve the experience for those subscribers. So that's one field that we have a huge amount of work in. Other things, industry and society, IoT, green energy, very important. I know there was a lot of stuff earlier, so I'm definitely not going to go into that out of my depth. But we're trying to make our own networks much greener, and that means turning on things and turning off things and understanding the cycles of when you have to turn them on and turn them off. Again, it's just a signature, okay? And I guess one thing that I was involved in last year, my team was involved heavily with the team in Sweden. We worked with a major Swedish car manufacturer, beginning with V. Fill in the dots yourself. And they created a cloud system that took data from the connected cars, stored this in the analytics system, and used the data from the cars to warn people when they were approaching incidents on a road. Okay? And the next phase of that was to apply machine learning on top of what we were doing. So this kind of public safety features were it was a very interesting, it's interesting to kind of work in those kind of things that are a little bit different for us. Like we spend so much time in kind of network stuff that when you get to kind of branch out into this, it's really interesting. And then to also feel that maybe you're making a little bit of a difference, to people's lives in safety and stuff. That was an interesting project for the team as well. So there are some of the applications that we put machine learning to. Obviously, I think you got some of the 5G talks as well. It's a big part of our automation in the 5G story that the networks will learn as well. So that's a lot about what Ericsson does. That's the problem space. They're the techniques that we apply. That's a good bit about Ericsson. I think when you give a talk like this, you can't help but have a kind of a personal reflection at the end of it. So line under the Ericsson bit, personal opinions now. Okay. So you kind of read around and it makes you think about the future. What is the future for us? And you look at some of the talks, and people predict a kind of a third or second or whatever industrial revolution associated with these autonomic systems. So as you know, industrial revolutions are good for some people and they're not good for other people. So people lose jobs, people gain jobs. So what happens? So you're all aware of a certain American politician who promised that he'd bring a lot of jobs back with the factories, particularly in the car industry. And a lot of commentators would have pointed out maybe to him that those factories may come back, but they're all staffed by robots, which could be a bit of a problem for the people who expected to get jobs out of that. And then I guess I started to think a little bit about my own industry, the software development industry. What does it mean for that? What does autonomics and machine learning mean? You could have the robots, will they be writing the code? Is code creation a creative thing, or is it a more methodological thing? I'm not equipped to say, But I think we've started a kind of a road of doing it. A lot of our technical strategies are built around doing things what we call source or software development kits. So that could be the first step. So we template out a lot of our code, and we provide these templates, and then you can combine these templates to build things with it. So I wonder, is it possible that you can take these and then apply machine learning on top of this and start to derive new applications on top of it? Now, I'm not suggesting you go in tomorrow morning and brain the guy who sits next to you that's working on SDKs because you want to hold on to your job. Don't do that, okay? It's probably a few years down, even if the machines are going to take over, okay? I think it's definitely interesting in our own history, and if you look, there's a website that a lot of data scientists use called Kargil. I don't know, maybe some of you folks use it. And Kargil is a website, kargil.com, okay? And you go on there and you load up your data set, and you load up what algorithm you used, and you say, this is what I was able to do with it, this is the accuracy I achieved with it. And basically, it's a kind of a collaboration website around machine learning, and they set a lot of challenges, and they're trying to push, they kind of pitch themselves as kind of pushing the boundary of what can be done with machine learning. And some of the guys from Kargil gave talks about it, and they looked towards the future, and one of the guys said that he predicted that he kind of classified it into two areas. Like, he said that there's still an element of the one-off creative things that only humans can do, and I guess even from my own experience, if you look at, there's still an element of humans having to be there, having to supervise, having to give something to the machine. Now, how quick the machines learn that, I guess is the key question. And then there are the kind of tedious and repetitive things that machines will be able to grow into doing more. So if you kind of mental picture maybe your supercomputers sitting on the couch watching Mrs. Brown's Boys, I can think of nothing more tedious and repetitive than having to sit and watch that. So I'm desperately looking to find some sort of original joke. And if you look at the humans, if you think of, like, say, the Paddy Power ads, where they walk that line between indecency and taste and intelligence, with some of the ads that they're able to put up, that's a thing only really a human can possibly do, and that's the kind of thing they said marketing was, for instance, one of the things that maybe humans are still going to be always best at doing that. This stuff doesn't even translate well from language to language, so can it translate well from language from humans to computers? So that's a kind of a little bit of a reflection on where things are going. I'm definitely not the person to say it's going to go this way or it's going to go that way. We'll understand it as we go through it. I think it's definitely clear, and I know from the talks before me, that machine learning, autonomics, etc., they bring so much. They're going to bring so much to people's lives. I know you covered the cancer research and all those types of things. Road safety in my own experience, that's a very, personally, I think that's a huge thing. So I think the systems will bring a lot of positivity. They might bring a certain amount of negativity. I think the final reflection I had was that anything that forces humans to become more creative, I think can only be a good and potentially even noble thing. That's the end.
Okay, thanks very much, Frank. So, questions for Frank?
That was quick.
Hi.
You're not a producer of Mrs. Brown's Boys, are you?
I'm not a producer of Mrs. Brown's Boys. I do work in Son, though, so it's not only the people at the top of the room who work in Son, there's people at the back of the room as well.
I don't recognize that.
The novel things which the machine learning discovered and the relationships, were those ones which you have not seen before, or did it just discover things that you already knew about faster and more efficiently?
That's an interesting thing, because what we have to do, a lot of these features, they move from a kind of research phase into production, and as part of doing that, we have to actually work directly with customers. And what we do with the customers is we present to them a number of, say, these incidents or these anomalies, and we verify with them as to what it was, and we have our own take on it. As I said, we have our kind of understanding of the domain ourselves. But yeah, we primarily will look at the output of what the algorithms have done. We'll understand to a degree ourselves, but we have to verify them with people, and these systems have to be tuned a lot. And we can only do that by engaging very closely with customers to make sure that they do. Because we do find relationships, we find known relationships, and then we find unknown relationships. And some of them are kind of noise, and some of them are things that are known. And then what we have done, for instance, in one case, we found too many relationships and they were just complete noise. So we retuned the algorithm again, and we were actually able to reduce it down to things that were more significant. So some things have a very obvious relationship, so you want to kind of filter out all those, and you want to get down to maybe somewhere between the obscure and, you know, the kind of known. But, you know, I think that's something that we're even learning ourselves. That's a journey to kind of to learn on. We'll get a certain amount of feedback, but we'll always be kind of tuning that approach.
Thank you.
All right.
Hey, I'm a radio engineer, also work in Sun. Question I have is, do you have any plans in implementing this kind of machine learning classification network inside Sun? And is it easy to get this information from the customer so you can do your research, since it's so important?
Without getting into our product roadmaps, yes, it would be the answer. We do. And we do have this within our products as well. Sorry, what was the second part of the question?
About data.
What we generally do is we will perform this analysis within a customer network. So with their permission, we will work kind of side by side with the customers as they're using the systems. And that was our experience, like that's our experience with all customers. We have a very close relationship. It's like what I said earlier, nobody is too keen on closing a loop on something or automating something straight off. They like to see that it's working first before they let you do it. So a lot of the work we did with our customers previously was around building that trust, building the trust in the system, and then once that trust is built, the guys will start to roll out the system in their own networks, and they'll become advocates. So you have to kind of seed this kind of belief with them. We believe in what we do, then we get a few guys on their side believing, they see it, then they allow the system to be closed, and then they start to roll it out within their own organizations, and our job is done, we move on to someone else.
Any other questions?
Hi, so I'm kind of thinking about a lot of the different things you talked about there. So you talked about automation and then industrial revolutions and this kind of thing. And what popped into my head was this idea of the Industry 4.0. And then you talked about autonomic management and this kind of stuff. And then what popped into my head was the kind of massive opportunity as a, you know, critical use case for 5G that is Industry 4.0 and this kind of stuff. And I was wondering if you're doing any work in this kind of space, because like latency is a major issue, and obviously in this kind of robotic world, and the kind of the role humans will have in that actually as well. And you kind of mentioned the higher order jobs and this kind of stuff, which is what I actually believe as well. Like there will be these kind of higher order positions in this kind of space. So I just kind of interested to see what your kind of thoughts on that was.
Yeah, so the question's around 5G, I think, is it, or what?
Well, it kind of touches on 5G with this Industry 4.0 and the application of machine learning in this kind of space, I guess.
Yeah, so, I mean, I think 5G, the natural thing is that it has to be shaped. So it hasn't even been standardized, or it's in the process of being standardized. So I would say 5G, we understand it, but we don't fully understand it. Okay, so it hasn't been shaped enough. If you look back at LTE, which was for people that aren't Ericsson, LTE is your 4G. It's the thing that you have now that's giving you the fast kind of broadband. What LTE said is it was going to provide a lot of the automation and machine intelligence within it. And what happened was it didn't fully kind of realize that. So 5G again makes the same claims, and I guess the latency thing is one thing. There's a lot of different concepts. Cells are gone within 5G, etc. So the way we do things will have to change. The way we form the beams within the network will have to change. The intelligence will have to come into that. Low power will have to come into that. So I think I probably didn't mention it, but like machine learning, machine intelligence will come into those systems, because these systems, the expectation that operators have on these systems is that they have the lower latency, they use less power, they are more efficient. And we can only do that, like I said, by optimizing the usage of resources. And it's my belief, and I guess my experience, that we've kind of got as far with a traditional approach to optimizing these things that only by using the kind of intelligent machine learning that we can actually go further into optimizing these things. So it would be part of the story, but even if I could describe it, I can't describe it yet, because I think we don't know enough about 5G to say how we're going to do it yet. We're only getting our heads around 5G in a sense, like we're part of that standardization with everybody else. There will be things that will come as standard within it. Then there's things that Ericsson will do on top of it to add value on it. And I think we'll only figure those out as we go through time. But like fundamentally, we have to employ those techniques. And some of the work that we do is around what we call analytics on the edge of the network. So what we're looking at is running these analytics systems in a very small footprint on a radio transmitter. These radio transmitters, which are our base stations, essentially have very low memory, not a lot of CPU, etc. So there's not a lot of space. So we have to be able to run the analytics very kind of efficiently on the edge. And people are crying out for us to actually run the analytics in an intelligent kind of way. Everybody wants machine learning running on it, but I think it's only when we start to apply it to things like distributed SON, where the systems will actually start to optimize out in the field, or sorry, on the edge of the network. That's when we'll get down to what are the actual techniques that we're going to do. And then our work has been in a centralized SON, as you guys know, so there are different layers of where all these analytics and automation functions happen. Some of them happen way out on the edge on devices, and some of them happen right back on central systems. So how that works in 5G, to be honest, we're still working that out.
Okay, we'll take one more question. I think we had a question here, Pat.
Hi, how are you? Very wonderful speech. I'm just wondering, when we talk about machine learning, we say, okay, we have like supervised learning or unsupervised learning, and we get information based on this learning, like say prediction, something like that, and we use those information for optimization, like say for network. I'm not quite clear about the scope of Ericsson jobs, but I'm just wondering, is there there's another kind of a machine learning method is kind of to learn the interaction between say the network and the customer, or the interaction between the system and the human. I mean, that kind of learning is kind of a very open. There are many restrictions on that. I'm just so my question is, what's your current interest in technology on the machine learning? I mean, based on Ericsson's interests.
Sorry, what's our current interest in machine learning?
I mean, for example, what's your more specific machine learning technology you're using or you're interested in your jobs? in?
Sorry, just
I mean, there are many machine learning methods or algorithms. What's your interest? What's your interest in algorithm from the machine learning background?
I guess what I
For example, artificial neural network or something like that, or reinforcement learning, something like that. What's your current interest in?
Yeah, well, I guess to one degree we can't go into the specifics of what techniques we're applying to do what things because it is business sensitive for us. I guess what I've been trying to do is describe some of the general techniques that we have applied, and some of them maybe in machine learning terms may be quite simplistic, but in terms of the industry that we're working in and where we're coming from are still on the kind of bleeding edge. Okay, so the things like the prediction, the reinforcement learning, recommender systems, all that kind of stuff, like clustering, they're the technologies, they're the approaches that I guess I explained that we tried to apply to the data. And I guess for us, a big part of it is the machine learning is one part of it, but when what the interesting or the tough bit of it is when we try to take that machine learning and try to apply it with, I say we call it the domain knowledge. Okay, so what is significant? What should we be showing to our customers and what should we not be showing to our customers? How can we make these systems more efficient? That's where, so we have a significant pursuit of machine learning, but it's not the be-all and end-all of everything that we do around that space. So our whole automation strategy is built around machine learning is one kind of part of it, okay?
Kind of a drive by the domain or by the customer.
Sorry?
I mean, it's not limited on some specific technology, but the drive by the domain of the project or the domain of the, or the needs from the customers. So it's open to any kind of algorithm.
Yes.
Yeah, it's just one part of the solution.
Yeah, well, I mean, our algorithms are pretty pluggable, like if that's what your question is. Yeah, I mean, we apply different techniques, and then we can reapply them. In fact, like one of the things that we have set up internally is something like what Kargil does. So we are looking at making machine learning kind of reusable within Ericsson. So techniques that people are doing, so we can redo different things.
All right, thanks.
All right, thanks.
Okay. Very good. One thing, Frank, you should have learned is you can deliver a damn good presentation without the aid of PowerPoint. You did really well. So well done. Thanks again to Frank. Okay, that wraps up Tech Talks 3. We have 2 more left in the series. The next topic is cybersecurity. We have another stellar line of presenters lined up for that one. I think it'll be really good. It's on August the 17th. And we're going to wrap up with the 5th one this year, an extra, and I think we're going to come back on the gaming theory to follow up on one of the speakers who didn't get to make a presentation the last time. So I just want to say thanks again, very sincere thanks to David, to Jane, to Frank. They were really good presentations. We came here to learn a little bit more, to be a little bit more enlightened. Hopefully we all have achieved that. We're all a little bit more connected here. And I'd also like to say a sincere thanks to Sarah Jane, to Rachel for organising this, doing all the background work for the Tech Talks, and finally to yourselves for turning up. Great audience again, and thanks for all your questions and participation. Thank you very much. Okay.